Okay, 7 times lucky. This is basically how many times I've done that. Let me move this down over here too, so you just have to excuse me. Just kind of an editing thing. So what this is, what we're going to talk about today is Chapter 6 in our course. It's going to be talking about configuring virtual standard switches and virtual distributed switches as far as their policies go. And this is really where you start to see the difference between a distributive switch and a standard switch. And so one of the biggest differences, and we'll mention this several times, but one of the biggest differences is that a distributive switch, you set policies on the port group level and then you can override them on individual port levels, whereas on a standard switch you can set it on the whole switch and then override on a port group level port group. So you don't have as much granular control. This is going to be part 1 of the 2 lecture. I'm hoping to make this about 12 minutes, but it's probably going to go 20. We'll see. And so we'll go right up to private LANs, and then we'll start the new lecture right over here with traffic shaping. And so here we have our environment. I've already went ahead and started it, and we have vSpar client on, going through Chrome. And when you configure a distributive switch, you're going to go to the network, and when you are configuring a standard switch, you're going to do that on the host level, or host and clusters section. And we're going to go ahead and go to host and clusters, and we're going to first just peruse them. We're just going to look at them and see what we have available. And so let me go ahead and open this. We're on the management tab, networking tab, over here in virtual switches. And notice that when we're on the distributive switch, there is no edit button. But once I hit these, this switch over here, it doesn't matter which one, we have an edit button, that pencil looking thing, and that's our edit. I'm going to go ahead and click on that. Now the reason why we don't have it for the distributive switch is because you can't create policies on an entire distributive switch. It doesn't work that way. It does it on the port group level and also allows on the port level as well. But on the standard switch, you can do it for the whole switch. And so this is where we're setting policies. Now, when we're talking about policies, let's go back to the book. There are 3 different types. You have security policies, traffic shaping policies, and policies, I don't want that, policies, and teaming and failover policies. And so that's really what we're looking at doing. Over here, the first policy that you can see that we can set is the properties. How big of a packet are we going to allow? Here we have security. I'm going to go ahead and set this. It was accept before. I set it to reject. And it's basically saying that I'm going to reject promiscuous mode. You also have MAC address changes and foreign transmits. I'm going to leave that at reject. Remember that that's at reject because when we go to the port group level, I'm going to show you how we can how that's reflected there and also how I can override it. Then you have traffic shaping. It's all about how much of the bandwidth am I going to allow. We'll talk about that in the next lecture. And over here you have failover, and this is all about load balancing and what do I do if there's a NIC card that goes out. Okay. I'm going to go ahead and hit OK. If I want to, again, this is where I'm going to set policies and make changes. Actually, it's right here. The policies for this switch. That's all the port groups on that switch. Over here is where I change it for the port group. So I'm going to go ahead and click on here. Properties is different in this case. This is the only one of these 3 that's different. This is actually about VLANs. Okay. Security, much the same, except you can see that we have these override checkboxes. Over here we also have override, and over here we have override. And what the overrides allow us to do is on a port group level, I can override the policy with a set on the switch itself. And it makes sense. So it makes sense to us that if I'm going to set a policy, I'm going to set a basic policy for everyone, and then later on I might be able to tweak that policy according to individual circumstances. Okay, and that's what this really is, but it's a port group circumstance. And so over here you can see that you can see the policy that is set for the port group, not port group, for the standard switch. But if I want to change it, let's say I want to override it, and I've decided, you know what, I'm not going to accept promiscuous mode on this port group. Now I've just rejected the or overridden. We can do it either way. The policy that we set on the standard switch on the switch level, and set it as a port group. I'm going to go ahead and click OK. And so hopefully this is demonstrating to you that how you would override it and what the policies are basically, and how you would override on the port group level. The next thing we're going to look at is we're going to look at how you do that on a distributive switch. Excuse me. A distributive switch. And all of the different things that we've talked about as far as all these 4 different policies that you can do exist on the distributive switch. But it's very important that we understand that the distributive switch, you set policies not for the whole switch, so not for every port group on your switch, but it's for a port group level. That's where you set it, and one port group's not going to affect another. And if you want to change it, override it, you would override it on a port level. So that gives you a lot more granular control. And where you do that, you're just going to go networking. So we could either come up over here and go to networking, or we can just come over here and click on networking. Okay, and so we're going to do it on port group level. So I'm just going to right-click the port group that I'm interested in changing, or configuring the policies. You can see actually over here, we can see a summary of the policies. So, and you see security policies, and you can see all these different types of policies. So we're going to show you how we can edit. Now, actually, I could actually click over here and say edit, and I'd go to the same place, the same exact place. The book has us right-clicking over here. It doesn't really matter because this is the settings tab. This is the settings. It's the same thing. Either way is fine. It doesn't affect anything. In general, we'll talk about this later on, but the name of the port group, this type of thing, I'm not really number of ports. Well, we did this when we created the distributive switch. Advanced, we'll talk about it in a little bit. Security, we should recognize this. This is exactly what we had for the standard switch. Traffic shaping, this is going to be a little bit different in that I have the ability to control it both on incoming traffic into the switch, which would be ingress, and egress, it coming out of the switch. In a standard switch, you only have one direction you can control traffic shaping. In this case, I can do it both coming in and out, ingress and egress. VLANs is going to be a little bit different. We'll explore this a little bit. You actually have more flexibility, but you still have the VLANs. This would be the same as you have the port group level on the standard switch. Traffic teaming and failover, basically the same idea. In fact, I see almost no difference except for the fact we have more uplinks. Monitoring, we don't talk too much about this right now. Traffic filtering, and then you have miscellaneous. Now let me talk about the miscellaneous for just a moment. Miscellaneous, I don't know why they called it this, but it's really about port blocking all. And so if I were to switch that checkbox right here, with this drop down to yes, that would turn off all. It would block, not turn off, but block all ports on this port group. Why would I want to do that? Well, let's say I want to have this entire network on this side be isolated for a while. Maybe I'm doing updates or something like that. Something's going on, and I don't want anyone to be able to talk to it. This is where I would make that change. And so instead of turning off every individual port, which would suck, because I might get the wrong one, I might forget to turn back on. So much more work for me. This is a kill switch that says turn off, turn on. That's it. And so I'm turning on and off traffic. When I'm done making my change, I'm going to come back in here. I'm going to set it back to no, and now they're all turned back on. No means I'm not blocking. Do you want to block? Yes would be to say I'm blocking all traffic. Okay, and so this really kind of concludes the section where we're just taking a look and feel of this policies, and we're going to start to talk in a little bit more detail. And so we're going to go back to the distributive switch, and we're going to talk about load balancing and failover. And that's going to be the same exact options and the way you configure it as in the distributive switch as well. So it doesn't really matter which one we go to, but I'm just going to go to the distributive switch. That way it's kind of the same as the book. The standard switch. And I'm going to come in here, I'm going to click on the switch, I'm going to say edit. And we're going to go to, let's see, I forget which one I'm going to. Oh, I don't want to do load balance. Yeah, let's do load balancing. Okay, so we're going to come over here into, this is the load balancing uh, option. And so we have a few different options in here. You have the first one, which is the default, route. Now when it says route, it means how do I get to which physical NIC do I take? That is a better way of putting it. Which physical NIC do I take? Maybe I have 4 physical NICs. Which one do I take? Route based on the originating virtual machine port ID. Okay. And this is, I think, probably a little better way of explaining it. I've got, let's see, where did it go? Oh, it's on the internet. Okay, so I went to this website, Hostile Coding, and they have a very good way of explaining this, if I can get it to scroll down, which apparently I can't. Come on. Come on. Don't know what's going on. This is weird. Okay, so maybe I just have to... here, I'm going to pause this real quick. Just excuse me 1 second. It turns out for some reason I can't move the website, but I do have a picture of their graphic, and I want to give them credit. Again, we got it from that website. And so here's an example of that type of load balancing. You have 5 different virtual machines that wake up. And those 5 different virtual machines are going to pick different NICs. And so the first virtual machine is going to take the first NIC available, second is going to get the second NIC available, third the third NIC, fourth the fourth NIC, and it kind of goes in a loop. And so the 5th one doesn't have its own NIC, so it's going to come up back to the top because it's a loop. And it's going to choose the first NIC. And so if you had 20, let's say you had 4. Here we have 4 different NIC cards. So if you have 8 different virtual machines, each virtual machine is going to have be sharing one physical NIC card going out of the network. And that's the idea of load balancing it that way. That way you have one, everyone shares, or everyone has approximately the same number of virtual links. Or they all share the resource. Okay, that's really not what I meant to say. And of the options, this is the one with the least overhead. The next one, and this one has the next least overhead, is route, meaning which NIC am I going to take, based on source MAC address. The idea is instead of letting this be a dynamic decision, I'm going to map it from virtual machine to that NIC card. Okay, that's the idea there. The last one I'm going to talk about is this one right here, route. And you notice it has a symbol there. It's kind of worried. Okay, and so route based on IP hash. The idea is I'm going to base it on the IP destination address, and so I'm going to send traffic that way as a dynamic decision because of where I want to send it. Now this is a great idea if you have Ether channel connected to this to the physical switch, or using Ether channel, but it also takes the most CPU, so it's actually a little bit more resource heavy than the other options. Okay, so that is load balancing. The rest of this is all about how do I take care of a failure if it occurs. Okay, and so the first one is how do I detect a failure? So let's say a NIC card fails. How do I know that it failed? I'm sorry, I'm just looking at something real quick. And you have the idea of, hey, well, how do I know if a NIC fails? Well, I can look at the light to see if it's getting power. Okay, so that's the idea. Is it receiving power, or is it receiving light? Whatever the NIC card uses as its medium, is it receiving that? Is the NIC card turned on? It has nothing to do with the configuration. So it could be the configurations are gone or they're totally toast, but the infrastructure here will not detect that. It thinks the NIC card's good, so it doesn't think there's any reason why to send traffic to a different NIC card. So that is link status only. The next one is beacon probing. This is the idea of sending out a signal and saying, hey, are you on? Hey, are you on? Hey, are you on? And it's not just says, are you on? It's going to read the status to see if it's working properly. If you have on the other end, though, something that's configured weird, or some other kind of problem, it could end up screwing it up. But again, if you have things configured properly, this is something that would be nice because it will tell you if it's misconfigured. Now, hopefully, it's not misconfigured. I'm going to go ahead and take it off that. Notice how these two don't like each other. The next thing is notify switches. The idea here is if there's a MAC address change, do I notify the physical switch? Now, what does a physical switch do? Or any switch? What does a switch do? It decides which port to send traffic out, and it does that based on the MAC table or the CAM table, whichever one you want to call it. And if you don't have an accurate CAM table, well, then you may as well not even have the switch. It's just very, very problematic. And so the idea here is if there is a change, I, yes, will notify the switch, or no, I will not. One instance where you may not want to is if you are using Microsoft Network load balancing with the unicast mode. That can actually be problematic. The last option is yes and no as follows fallback. Meaning, let's pretend for a moment, you have to pretend, let's pretend for a moment that I have more than one NIC card. Okay, I have one in the active, that's the one we're using, and one in the standby. You'll actually have quite a few others, because otherwise why have any load balancing? But still, let's pretend that we have at least two, one in standby and one in active. If the one in active goes bad, it is removed from the active, and the one in standby moves up to active. That's the way it should work. But let's suppose that the one that was active in the beginning and it failed, it's now working again, and the system detects it. Do you want it to move back into the active area, or do you want it to stay in standby? If it moves back in the active area, do you want this one to go back down, which is the assumption? The standby NIC that is now active will be moved down to the standby, if the answer is yes. However, if you have the answer no, it means, okay, if the active one goes out and the standby one takes its place, the standby one will remain the active one even if the old one, or the one that was active, is reconfigured and it's working properly. So which one do you want to choose? Well, if they're both equal NICs, I would leave it at no. There's no reason to move it back, because let's pretend for a moment that that NIC card might go back bad again. Then you have a network that goes on and off, and you're going to have connectivity problems. If the NIC that was originally active is a superior NIC card, you might want to turn it back on to yes. I do want the original NIC to be the dominant NIC. And so that's an important idea. Hopefully, hopefully it's explained well. I'm just looking in here to see if I've messed anything up. I mean, missed anything, not messed anything up. The next thing we're going to talk about, and that'll be the last topic for this discussion, is I want to talk about VLANs. Now, VLANs are not designed here at the switch level on a standard switch. They're designed, or they're configured on a port group level. So we were on the standard switch here, editing it for all ports, meaning the whole switch. If you want to configure a VLAN, you do it on a port group level, which makes sense. I don't want the whole switch to be on the same VLAN if I'm going to have VLANs. So I'm going to click over here, or at least sometimes I won't. And under properties, the property tab is different, and you type in a name of a VLAN, and you say, okay, well, what number do I want? Well, maybe I want 7. So I'm going to come in here, and I'm going to say VLAN 7. Okay, now that whole port group will be on VLAN 7. If I want more than one, I kind of have to say all. And that just shows you how it's not that flexible that way. So your port groups have to be on all the same VLANs here in this case. The distributive switch is different, however. So let's go back to networks, or networking, I should say. And I'm going to configure. Let's first go with just VLANs, and then we'll talk about private VLANs. And so I'm going to go to the VLAN section. Again, we're on a port group level on the distributive switch. And here I have the ability to say no VLANs, a VLAN, and here I can choose the VLAN number. I wouldn't choose 1, but maybe 7 or something like that. Hey, maybe I want this to be trunking. So trunking would be a line that goes from, let me, one switch to another traditionally, or from here to a router. It just has to be able to support this line, this port, this group. It has to be able to support more than one VLAN. So I don't have to choose all of them. I could say 1 through 9, and that would be 1 through 9. And then you have an extra idea in VMware. This is the idea of a private VLAN. Okay? It may not just be in VMware, but you have this idea. It's a VLAN that exists solely in the VLAN, the virtual networking. So what I'm looking for in our infrastructure, and you have 3 different settings. Okay, you have promiscuous VLAN, then you have secondary VLAN, private VLANs, which would be community and isolated. And I'm going to grab a picture real quick. Okay, and so let me go ahead and go to the website. This website is labeled right here. I don't want to mispronounce their name. But they have a great graphic here. I'm really impressed with it. It makes it easy to understand. And so we're just going to look at that picture. And so the idea is you have 3 different types of VLANs that you can, private VLANs I should say, not VLANs. You have all the different types of VLANs you want. But in this case, in your VMware, so here's the real world, here is the virtual world, you have promiscuous, then you have community, and you have isolated. Promiscuous is your gateway, and you will have devices in the promiscuous VLAN, private VLAN, and it's the gateway for the other 2 types. These are secondary types. You have community and you have isolated. And in community, everyone in this community can talk to each other, and they can talk to the promiscuous directly. They can't talk directly to anything else. Okay? So you can see these all can talk to each other, and they can talk back and forth between the promiscuous. The isolated, on the other hand, I should say, can't talk to even each other in the isolated VLAN. So this VMware cannot talk to this one, cannot talk to this one, cannot talk to this one, but they can still talk to the promiscuous. And so that's the difference. And so when you're doing this, because the promiscuous is the gateway, you can't have these other 2, community or isolated, without the promiscuous. So we choose which VLAN, what type of private VLAN is that we're part of on this group by this drop-down box, because I've actually created them in another setting that I'll show you in just a moment. So maybe I want this to be isolated. I say, okay. Now I'm going to go and show you where I created the private VLAN. In this case, we're going to create it not on the port group level, but on the distributive switch level. I'm going to come over here to settings, and you'll see that you see edit private VLAN. In here, I'm just going to click on here, and you'll see that we have 1 is community, 2 is community, 4 is isolated, 5 is promiscuous. Now I can change these because you have little drop-down boxes. That's a community, now that's an isolated, and I can only have 1 isolated. Watch. I put another isolated. The way I've got this designed, I can't have 2 isolated. Okay? And hopefully that makes a lot of sense. And what we're going to do is we're going to pause here, and I'm going to this. So this concludes our discussion for Chapter 6, Part 1.